Let's learn something from scrolling today. This is the difference between capacitors and inductors. If your physics teacher had explained it like this, you'd probably have made it into MIT or Caltech by now. These two are like evil twins in an electrical circuit. They look similar, but their personalities couldn't be more opposite. Let's start with the capacitor. Its structure is actually simple. Two metal plates separated by an insulator. When you connect it to a power source and close the switch, electrons flow from the negative terminal toward the positive one. But since the insulator breaks the circuit, electrons start accumulating on one plate. The other plate, under the influence of the electric field, loses electrons, becoming positively charged. And just like that, a potential difference is formed between the two plates. Now disconnect the power and replace it with a light bulb. When the switch closes again, those accumulated electrons naturally flow from the negative side to the positive, causing the bulb to light up. That's the capacitor's basic function, energy storage. Now let's see how it behaves in a real circuit. In this parallel circuit, when the power is on, electrons flow toward both the light bulb and the capacitor. The capacitor stores energy at this point. If the battery suddenly stops supplying power, the capacitor, thanks to its internal potential difference, starts releasing the stored charge, briefly keeping the circuit alive. When the power source is restored, the capacitor charges again, waiting for the next cycle. You can think of it like a water tank. When water pressure drops, or the main supply cuts off, the tank releases stored water to stabilize the flow. That's exactly what a capacitor does with voltage. It stabilizes fluctuations. Now let's look at the inductor. Its main structure is just a coil of wire. Here, let's recall Faraday's law of electromagnetic induction. When a magnet moves near a coil, the changing magnetic flux induces a voltage, generating current. Similarly, when current inside the coil changes, it creates a changing magnetic field, which in turn induces an opposing current. Let's look at it in a real circuit. When the switch closes, current flows toward both the inductor and the bulb. At first, the inductor's current increases slowly, because as the current starts flowing, it creates a magnetic field that opposes the change, acting like resistance. Once the current stabilizes, that resistance disappears, and since the inductor's path has less resistance than the bulb's, most current flows through the inductor back to the power source. Now when you cut the switch, the power stops, but the magnetic field in the inductor collapses, and as we mentioned earlier, a collapsing magnetic field induces current in the opposite direction, so the inductor releases that energy and keeps the bulb glowing briefly. So yes, both the capacitor and the inductor store energy, but one does it through an electric field, the other through a magnetic field.